Okay, well, thank you back for after the brief coffee break. We now have Peter Belmann from the University of Bielefeld speaking about the CAMI evaluation.
Yeah, hi everyone. My name is Peter. I'm a PhD student from Bielefeld and I'm working on a framework for the continuous assessment of metagenome interpretation. And I divided my talk in 3 parts. In the first part, I would like to talk about the initial idea, about the concept we had about 2 years ago. Then I would like to present the status so far of the framework, and the tools are already included in it. And at the end, I would like to talk about ideas how to optimize it and how to maybe extend it. So on this slide, you see on the left side our initial requirements on a competition, on competition management, and on the right side, you see CAMI as one example. So of course, we wanted to manage participant user data because we wanted to keep track who is uploading what. We wanted to make sure that everyone agrees on the license agreement. So far we have in CAMI about 100, more than 100 user accounts. We wanted, of course, to include participating tools based on different data sets or different parameter settings of each tool. In CAMI so far we have 35 tools submitted for different data sets and again with different parameter settings. We wanted to manage the access to the data set, so we wanted to make it as fast as possible, so that's why we stored the data in different regions of the world using Amazon. So we stored it in the US, in Singapore, and Europe. Then we evaluated the tools. At the moment, we have, I think, about 6 evaluation tools. Not all of them are currently included in the framework, but will be, of course. Once you have evaluated the tools, you want to compare the different results. So in case of assembly, we have 13 tools, and yes, so we want to aggregate this in plots, for example. And the last point here is, in my opinion, the most important one, that we want to ensure reproducibility. So we wanted to make sure that each part of the evaluation can be reproduced by users. So he could download a specific evaluation tool, for example, and rerun it on his own system. And so far we have 41 tools that are based on different programming languages and depend on different libraries. So the first point here sums up the previous slide. So the question was, how do we handle tool and user data? And the second point is, how could we extend such a competition? So what if a user says that his tool behaves completely different on a data set that is so far not included in CAMI? How could we manage it to add this to our evaluation? Or of course, even after the first CAMI competition, there will be new tools published, new binners, new profilers, new assemblers. And we will continue to think about how to improve our evaluation, maybe come up with new evaluation methods. And all these points, these questions, led us to this concept. I call it the continuous evaluation concept. So you start here, you start adding your data sets, you start adding your tools with different parameter settings, you add your evaluation tools, and then you just run it, right? So you start running the submitted tools based on the different data sets and collect those submitted results and evaluate them. And one requirement for this is, of course, that it has to scale, because I mean there are many tools, and if you just add new data set, you will have to rerun everything. And one advantage of this is that you could, for example, benchmark directly the runtime of each tool based on parameter settings, based on the data sets you choose. And once you have those submits, you of course evaluate it, and you need someone who checks the evaluation results before it is made directly public. So that's why it is first just accessible to the admins, and once they approve the evaluation, it is made public for other users, so that it, for example, is directly accessible by using a URL, so static links. And the next part, so once you have your single evaluation results, you somehow want to aggregate those in plots, for example, so you want to visualize it. And one point that is of course, advantage here is that we want to offer a direct download of not only the evaluation tool, but also of the participating tool. So at this point, a user could actually decide what kind of tool he wants to use for his specific use case. But also this point is for bioinformatician important to maybe to decide, okay, so again, so my tool, for example, behaves completely different on a data set. So we could, for example, add a new data set. So that's why this arrow here goes from compare to add again. And you started from the beginning and collect those results and try to somehow to aggregate this and present it to the users. So at the moment, this framework consists out of 3 parts. So one part is this whole organization. So how do you organize a competition? How do you create user accounts? To who you want to allow to log in the framework, who not? Then the second part is the standardization part, because if you want to develop such a framework where you can exchange those tools, you have to think about standardization. And the third part is the evaluation part, where you have to think about scaling and how to run many tools, maybe on multiple machines. And there are many parts so far missing. I will present a few of them at the end of my talk. So one part which is at the moment not fully implemented is the rerun part, so where you want to rerun you build the participating tools on different data sets. So the most boring part was the organization part, where we had to create user accounts, where we had to handle the competitions, for example, deadlines, so that no one is allowed to upload something after a date. We also wrote different parsers that ensure that anything that is uploaded to the framework first is checked. And we have multiple user roles. So one is participating role, but also admins, which we need for example, to check the evaluation results before it is made public. So the second part here is the standardization. So we noticed that it's maybe difficult for someone who is not familiar with computer science to install different kind of software. I mean, again, we have about 41 different tools based on different libraries, dependencies, and so on. So we wanted to make this as easy as possible. And the second part here, we noticed that there are divergent formats and interfaces for common tasks. What I mean here is that there are tools that may be doing the same, but still demand a different input type. So for example, different compression types. Okay, so there are tools, for example, assemblers that take just raw reads, another one that just take compressed reads. Also file formats, so in spite of the fact that FASTQ is the standard for assembler input, there are a few ones that still take FASTA as an input. Then data formats, so in case of assembler input, you have 2 versions like interleaved and splitted reads. And there are tools where you can execute it just with one command, but also there are tools where you have to run multiple binaries. And all this is for someone, again, who's maybe not that familiar with the command line, difficult, because he would have to pre-process everything. He would have to prepare it, and it's not easy, in my opinion. Yeah, and that's why we started with this standard called BioBoxes. It is a standard for creating interchangeable bioinformatics software containers. I started it together with Michael Barton from JGI and Johannes Ströge, who is also here today. Yes, so our solution to the installation problem was the usage of Docker. Docker is a platform for creating encapsulated Linux environments, and Docker tries to solve the development versus the production problem. So it means that if you as a developer working on any kind of application, you always want to make sure that it runs on any kind of other operating system. And this is solved by Docker. So you can see Docker as a lightweight virtual machine. Lightweight because it reuses parts of the host kernel, and this is also the reason why it's incredibly fast, because you don't have to boot a whole operating system, you just like starting a process. It is shareable, so Docker has its own repository called Docker Hub, where you can upload your software and anyone else can download it on his own machine. So how does BioBoxes work? So what we are doing actually, we are grouping software in different types, and we are assigning these types interfaces. So in this case we have this interface or type assembler, and we standardize the input and the output. So in this case we just accept a list of FASTQ. We demand that the FASTQ is always gzip and interleaved, and we demand that the output is always in FASTA format. We also provide a configuration file that further describes the input data, and also we have a configuration file for the output, because we hope that one day we maybe can connect those different BioBoxes, since we describe the input and the output data anyway. And when you have this standard, it allows you to interchangeably use different BioBoxes of the same type, because the input will not change and the output will not change too. Yeah, so at the moment we have 8 different interfaces. So for assembler we have a short read assembler interface, read-based assembly evaluation, reference-based assembly evaluation. In CAMI at the moment is just a reference-based assembly evaluation used, but I think in later we will use read-based assembly evaluation too. For binning we have 3 interfaces. 2 of them are for evaluation, and these 2 are at the moment are not official, because I agreed with this Michael Barton and Johannes Tröge that we will just make or sign it as official when we have prepared test cases, so that a user who writes a BioBox can make sure that his BioBox implements the standard correctly. And also for profiling we have a profiling and profiling evaluation interface. We also provide a command line tool that allows you to skip this configuration file I mentioned here. So you just give it the input, you specify the interface, and it will directly run without any kind of configuration files. But still you would have to use Python. It's up to you. Okay. Yeah, so the evaluation part. Evaluation is at the moment semi-automated, so it means that I have to take care that I choose the right evaluation container for the specific type. So I have to take care that I choose, for example, for an assembler, just assembly-based evaluation. So that's why it's not fully automated at the moment, at least. So what it does, actually, it just starts multiple evaluation containers based on what I decide to run. At the moment, everything is executed on just one machine. This will change in next weeks, because of this, actually, you will at the moment not find each results online, because we had to run different evaluation methods outside of this framework. And at the moment, it is a little bit difficult to include those results directly in the framework, but this will also change. Yeah, so once they are done, it basically collects the results. I will show you an example how it looks like. And it shows and enriches the data. And with enrich, I mean, for example, if a tool produces a tab-separated file, it allows you to browse it or to search in it. It allows you to download it in different kind of formats. It also combines it with data from the database, which I will show you in my next slides. So here you have one example of an output of an evaluation bio box. In each evaluation interface, we define that the output is always a configuration file, so a configuration file additional to the existing files that are produced by the evaluation method itself. And what you see here, it is just an array, right? So here is the first entry, and here is the second one, and you can add as many as you want to. You have to give it a name, you have to give it a description, then you specify the type of it. So here is a tab-separated file. It could be also a PNG, HTML, whatever. You specify if it is directly included in this description file or if it's not. Here it is not because it's in a different file. And so you can add multiple of those evaluation entries. And the framework just takes this description and shows you to the website. So what you see here again, this is the name that you saw in the previous slide. The description is here, and this is the table that was also described. And again, it allows you to search for values, for example, or to download it again. What you also have from the database is that you have that the BioBox's image itself, so the evaluation method itself, is specified. So you could directly download the evaluation method. It is, of course, a container, so it will directly work on your machine. We have specified the task for it, so it means that this is the argument for the container. And you can share this result with this static link. And also the anonymous name that we are creating for each result is also here stated. Okay, so that's where we are at the moment. I'm not sure if these are the latest numbers because we just added last week new winners and new assemblers. So far we have, I think, 13 assemblers, and of them we have 6 containers available. 80 submitted results so far, so based on different parameter settings or different data sets. And at the moment, 80 single evaluation results. But of course, we have more aggregated evaluation results which are here not listed. For profiling, we have 11 tools, 8 containers, 209 submitted results, and also 209 evaluation results. For binning, we have more evaluation results, single evaluation results than submitted results because we used multiple parameter settings of the same evaluation for the same tool. So that's why we have here more evaluation results. Okay. So there are many things I want to optimize, I want to extend, I want to update. So one of these are that I want to use a cluster. So again, at the moment I'm using just one machine. Aggregated presentation is important since we want to all these plots that you will see in the next talks must be available through this website. The rerun part I already mentioned, and I also have an idea how to connect maybe this platform to other platforms. And so so the idea for the scale up is that I want to use Mesos. It is a cluster manager used by Twitter in order to distribute those Docker containers on different host machines. So I will start them, it will directly distribute it on different machines, and the framework will collect the result from the network file system. Okay, so for the aggregated presentation, I agreed with Peter Hoffmann and Stefan Jansen on this specification for a container that implements this definition and could be directly included in this framework to produce those plots which you will see in the next talks, but still it must be implemented from the framework. Okay, so we run submitted tools. So here again the question, what if multiple tools behave completely different on a data completely different on a data set that has CAMI not offered so far. So we would have to take the collection of all available tools and rerun them on the different data sets. But before we can start with it, we have to ensure that the participated tools are implementing the standard correctly. And also, again, I have to implement this, that we can run the containers on different host machines, because otherwise it will just take too long. Okay, so at the end I would like to talk about an idea I had just last week. Okay, so in the framework we have we have an API that allows you now, for example, to use curl and to ask this framework, okay, what kind of evaluation methods are included, right? And I would like to extend this API and allow other platforms to use this data, to use this information. I want to give you one example how this could be used. So there is a platform called bio.tools, and bio.tools is a registry for different bioinformatics applications. So what you see here, I hope you can see it. A user, so a scientist, could choose the input and the output definition. So the input he wants to give to a tool and the output he wants to get from a tool. And this platform will just list different tools that are included in this platform. So, and I think it would be a cool idea if such a platform could use our information to show different, or at least to link different evaluation results directly by using this REST API. Okay, so yeah. What I would like you to remember is that BioBoxes is the standard for creating interchangeable bioinformatics software containers. What we have so far is a standard, of course. Still, we are working on it. We want to improve it. We want to extend it. We have so far a competition management, so we could start directly a new competition because everything is already implemented, and the evaluation is also available, but at the moment semi-automated. What I'm of course going to do is to optimize it further, to add new components like usage of cluster technologies, to make it faster, and of course to show the aggregated results, these plots that you will see in the next talks. Okay, so thank you.
When you talked about running on multiple hosts, using Mesos, and then aggregating results on the shared file system, so you're talking about within a single institution then, or across institutions? Have you thought that far?
Well, for Mesos, I think it doesn't matter, I think. So you just start a Mesos slave, for example, and link it to the master machine. So I think it would not matter, but still I have to collect the results. That's the problem. So I could start these containers anywhere. That doesn't matter, but I have somehow to collect these, and I'm not sure. I don't know. I would have to think about it how this could be accomplished if it is on a different location.
Right. You may need a different approach.
Yeah.
Just the shared NFS.
Yeah.
Okay, we should talk.
Yeah, sure, of course.
Of course, I would be interested how to use like computational infrastructure which is available somewhere else, right? To speed the whole process up.
Yeah.
It's a evaluation of the high complexity data set for assembly takes. I mean, it takes weeks on a single machine.
Absolutely.
Right. So if you add a new data set, it would be nice. Well, of course, the computation of the assemblies takes also a while, but it would be nice if we could speed it up so that it's sort of an interactive kind of page where people can upload a new tool in a Docker container and then will get their results within a few hours, maybe.
Okay. Yep.
We already talked with David about that we should put all the evaluation results in the database. If we ran it on different machines, as long as they have maybe a connection to the internet, if we add something that all the results are actually uploaded to a database, that would solve this issue of getting the results, and also helps into the automation of getting the comparable evaluation of tools in comparison to each other.
Yeah, sure. No, this of course is something I have to take care of, that you, for example, could include your evaluation methods directly, or your evaluation results directly into the framework. That's what you mean, right?
Yes.
Okay.
So if there's a database available, it would be really easy to.
Yeah, there is a database available, but the problem here is that you have first to talk to the framework in order to upload this and to somehow to organize it, right? So you have to assign those results somehow to the tools or to the data sets. But maybe I can explain it after the talk. Okay. Yeah, sure.
Analysis of a data set isn't just about individual tools, but all about how they work together. To what extent have you thought about coordinating the evaluation of entire workflows and how to standardize that in much the same way? I mean, there are things like the common workflow language and those sorts of things that are sort of moving along.
Yes.
But
So I talked last year with someone from common workflow language that we, for example, could use fireboxes directly as part of common workflow language. So you just write a wrapper with common workflow language tools to start those fireboxes. And once you have this, you can, of course, build with common workflow language a workflow out of different fireboxes. Yeah. You don't even have to use them fireboxes. So just one part could be a firebox, and everything else could be something different.
then you lose some of the nice sort of common interfaces that you've built by putting that extra work on top of the Docker container.
Sorry, could you repeat?
But I mean, if you don't use fireboxes, then the idea is that you've got some unified input and output arguments. So if you start to develop workflows that have a mixture of fireboxes and just plain Docker containers where you have multiple entry points, for example, then you've lost some of the advantages of using your system. Right?
Yeah, I'm not sure to which extent we can combine it with other technologies. That's something I have to think of. I don't know.
One last thing. So with the parallelization, you use something like Docker Swarm or something to sort of connect up all of your containers?
Well, the problem is I actually don't know what kind of technology is the best. So that's why I want to use Mesos, because on top of Mesos you can set up different frameworks. I think just in February now you can set up Kubernetes from Google, for example, which is similar to Swarm. You can directly set up on Mesos, but you can also switch it with different technologies. I'm not sure if Docker Swarm is already available. Yeah.
First a comment, I think your comment about connecting up the workflows is really important because, for instance, like with the binning, they used as their input a gold standard contigs, whereas I think it's really important in practicality to figure out, which assembler should you pair up with which binner or which should you not, kind of thing. And then a question, one of the most important things for users or end users is runtime and RAM usage and things along those lines. And so is there going to be a push to sort of, integrate that sort of information? Because I know if you do this sort of like Mesos remote execution with a bunch of different heterogeneous nodes and things like that, you might not be able to do that. But at least right now, when you're on a single machine, you could get runtime execution.
What you could do with Mesos is you could specify what kind of type of machine you use. So that's the only solution I just can think of right now. So you could, for example, for benchmarking, you could say, okay, so I just want to run these containers on one specific machine type, architecture, whatever. Okay.
And so is there going to be a push to get
Runtime? Yeah,
Runtime
of course.
information.
Yeah, I think that's, if you continue with this, of course, it will be important.
Well, we
yeah.
thought of running all the tools again because we have the containers available,
Yeah.
but it turned out that it's probably, it takes, well, just too long, right?
Mm.
So we were focusing on other things, but of course it's interesting to see the requirements you have for the different tools.
Mhm.
Because the best tool you might not be able to run on in your local institution, right?
Exactly.
So, yeah.
And it very much depends on which parameter you use. I've seen, for example, some tool offers if you have a big machine, you can use more RAM, which makes it run faster. If you have a small machine, it's just slower.
Mhm.
So when you consider input standardization, you also considering the parameter standardization? Like the parameter settings are sometimes very challenging. So I
Okay.
think one of the useful feature would be to standardize parameter settings.
The parameter itself. Yeah, so if you want to run a BioBox, you specify a task. So we call it a task. It's just
Oh, it's a parameter setting.
it's a parameter setting, right? So so you could choose
But
that.
most of the cases, parameter settings are like default, right?
Yes, but you could also specify, if you think of a parameter setting that it's better than the other one, you could just specify it and add it to the BioBox. This is possible, yes.
So you can think of, like, if you think of an assembler which has different parameter settings for, let's say, a single cell assembly, for an isolate assembly, for metagenome assembly, you can define 3 different tasks for these 3 different kind of parameter, like default parameter settings for whatever, metagenome or single cell assembly. And you can, well, what we did is like defining the input, right? Sometimes you need a shuffled FASTQ file. Sometimes you need the reads in different files, depending on the assembler. So this is something we standardized already. And then within the container, you have to make sure that it fits your your parameters for your tool, basically. Otherwise, I think, well, so you can. So I'm sure there are some parameters you can standardize. Others you can definitely not. I think because it's too specific for different tools.
Yeah, because sometimes the parameter setting is very sensitive to a certain data set. So
Yeah, but how do you want to? Well, yeah, that's hard to standardize. I think.
right, so I'm just curious about that kind of information you're in mind.
Mhm.
The sensitivity, specificity,
Yeah.
trade-off,
Yeah.
for instance.
Well, see, that would be nice if this would be a result of the challenge, that you could say, okay, for this assembler, if you have, let's say, a low complexity data set, this is the right parameter setting,
Right, something
right?
like
And
that.
this, and then you just use this BioBox task for assembling a low complexity data set. For a high complexity data set, a different task might be better. And this way you can at least come up with some, like, very rough kind of criteria how to run such a BioBox on certain data sets. Or I can think of like a binning or a profiling tool. If you have a data set which is from a well-known environment, like an HMP data set, right? It's probably something you can give as a parameter to the tool, right? Or you can make some sort of suggestion that for a particular environment, some tools are definitely better than others, right? Because if they were developed during, let's say, the HMP project, they rely on reference genomes, let's say, right? And they perform best on these kinds of environments, and they might perform very poorly on other environments. And it's just important to know.
So back when you were mentioning about integrating it with other sort of technologies, have you thought about Galaxy at all? Because that would, it seems like it could be relatively straightforward to just make the Galaxy interface to each one of these different bio boxes that you have.
I think it's the same like with common workflow language. You just have to write some kind of wrapper with Galaxy or common workflow language to wrap such a BioBox. It's possible, sure.
And they they run Docker containers, so Galaxy can submit Docker containers as tools.
Yeah, I think so, but I'm not sure if you can submit single parts of a workflow in different containers, or you just submit a whole workflow in one container. That I don't know.
I think one comment for, in general, containerization and Docker and everything, it's like software is always subject to changes, so it's never one state. So when a new software version comes out, people want to use it. And also with the parameter settings, something that might be good now, it's not good in a month or so, or they introduce new parameters. So when we Docker makes it possible to have revisions, to have software checks and everything, but who's gonna have the control over versions and keeping the resources? Because I think if we keep our containers as CAMI containers, it's a good reference, it's kind of reviewed, but it's gonna be old in a year, and we don't have the manpower to curate those containers. And if you leave it up to the submission people, then you have to make sure that we still have access to the versions that are used and the revisions to make it transparent and yeah. So I think that's one open question.
Well, I think the developers should take care of their.
If you delete a container on the hub, and then you.
Well, if you include a container in such a challenge, I think we have to make a copy of this container.
Yeah, but I mean, it's a continuous process. So if somebody decides to change the parameters for, I don't know, a task that is good for, I don't know what, freshwater metagenomes or so, then who's gonna track the changes? Who can judge what's happened? I mean, that's the problem.
One could foresee, like in a future CAMI competition, adding an additional requirement instead of just submit a Docker container. Now it could be something like submit a Docker container that's created by some sort of webhook on a GitHub repository.
There would be one solution to it.
That way, whenever the developer changes it, it just submits a new version of the Docker.
For example, or you do pull requests
Yeah.
on a CAMI controlled repository which builds the containers, and then you can track the development changes.
Yeah, exactly.
It would be quite nice to have like one repository where every group can submit their Docker.
I think it has to be in the middle. It has to be not totally controlled by CAMI, but we cannot leave it totally up to the users because it's going to be a mess.
Yeah, absolutely.
Mhm.
I wanted to comment on output specification.
Mhm.
So you showed a slide regarding an assembly container which outputs FAFSA.
Mhm.
And in the previous talk, there was mention that it would be nice that assemblers would output graphs instead.
Mhm.
So boxes are super useful, and also they have a high responsibility when it comes to setting incentives to the developers.
Mhm.
Because many assemblers can output graph,
Mhm.
but if the container wants a FAFSA,
Mhm.
then you have no incentive to output graph form.
So we notice that of course there are other files also important which we cannot, of course, not standardize. It's for some files it's impossible. So we started to integrate something like a cache directory, so where this will also be available after you run the BioBox. It will just not. I mean, you will have the path to this directory where other files will be placed, but still, I think it makes sense to reference just a fast A file for the end user who will want to use an assembler. Okay.
Okay, well, thanks again.